All right, hello everyone. So today we're going to have a look at it like one of the most powerful pieces of kit you can have when solving problems in trigonometry. Sorry, lost it there. It's called the sine rule, okay? Or as I like to call it, the opposites rule, and you'll see why in a second. So I am going to just perfect the went. So I am going to show you what the sine rule is and then prove it to you. Okay, so take any triangle, and this means any triangle. So we're kind of moving away from the idea that it has to be a right angle triangle, even though we're using sine, which we have associated right angle triangles. Okay, now you'll find this in the log table, so you don't have to remember the formula, even though it's the easiest formula in the world to remember. So you take any side A, and the angle opposite it we'll call capital A. You take any other side of it, B, okay, and the side opposite that is capital B. And then we take any other side, C, and the side opposite it has an angle of C. So we have three angles, capital A, B, and C, and we have three sides opposite these angles, A, B, and C, correspondingly. And the sine rule says that, and this is a ratios rule, it says that the side A divided by the sine of the angle opposite it, this is where the opposite rule comes into it, is equal to the sine of B, the side of B divided by the sine of B, but it's also equal to the sine of C over, C. And a mess of that, but there you go. So you pick any two and you can solve, so long as you know three pieces of information. Any three pieces of this information, you can solve the fourth piece. Okay? If I have A and C, I can solve. If I have B and C, I can solve. So any two and you can solve. It's a brilliant piece of kit. It actually helps you quite a lot. So I'm going to prove why this is true. Because you'd probably think to yourself, well, that's a load of baloney. I don't believe it. So what I'm going to do is I can pick any of them to prove. I'm just going to prove the first two. Okay? I'm going to do a proof. Okay? A over sine of A is equal to B over sine of B. So the easiest way to prove it is to draw it. So let's go draw one. Draw a triangle. Okay. So there we go. So triangle is drawn. Everyone's happy so far. I've drawn a triangle. Happy days. So I'm just going to put in my labels. Call that A, which means this is A. We'll call that B, which means this is B. And don't need this because this is C and that's C, but we don't need that. We're just doing the A, B bit. Okay, so how do we figure it out? Well, let's have a look. In order to kind of prove it, we need to do one little piece of work, okay? We need some way of figuring out the sine of A in terms of B. So my suggestion, you can take me up on this, is drop a perpendicular down. Okay, just drop a perpendicular down. And now would it be true to say that sine of A is equal to this line, we'll call it H, over B? Would that not be true? Okay. And would it also not be true to say that the sine of B is equal to H over A? Check it again. Sine is equal to opposite over hypotenuse, opposite over hypotenuse, opposite over hypotenuse. So there's nothing wrong with what I said there, is there? However, I don't want H. I just want A and B and capital A and capital B. So let's rearrange these. So another way of writing that would be H is equal to B multiplied by the sine of A. Another way of writing that would be H is equal to A by the sine of, yes, you've got it, B. So that means, therefore, oops, dropping that. Therefore, would it not be true that if both of them are equal to H, then make them equal to each other? That would mean that A by the sine of B is equal to B by the sine of A. Now, if I divide both sides by sine of A, sine of B, as a product, then this becomes A sine B over sine of A by the sine of B equal to B sine A over sine of A by the sine of B. And you can see what's going to happen now. Use a different color. Cancel. So A over the sine of A is equal to B over the sine of B. And that's proven. So that's your proof. Isn't that pretty cool? It's a lovely little proof. I love it. Just by one simple line and it suddenly works. Okay? It's really, really, really cool. Now, I'm hearing you cry to me saying, sir, that works fine. Okay? But what happens if you have an obtuse angle? In other words, they're all acute. They're all less than 90. And it'll work for a 90-degree one as well. But what happens if they're all less than 90? How the hell are we going to make this one work? Well, let's have a look at that. Let's do that. Let's prove that A over the sine of A is equal to B over the sine of B. Okay, but this time, let's do an obtuse angle. Let's make it really obtuse now. Try and make it as obtuse as I can. Okay, so this is A. Okay, and that makes that A. And let's say this is B. That makes that B. And this is C. And that makes that C. So I want to prove that A over the sine of A is B over the sine of B. So the question is, I can't drop a right angle here, can I? No, sirree, I cannot. So when you can't drop one inside, drop one outside. Okay? See what I'm doing here? I'm creating a little right angle on the outside. So I've got a little right angle going here that incorporates A. Okay? So what do we know about this little angle here? So this is still going to be H like in the previous one. So this little angle here is 180 minus B. Would that not be true? So whatever B is, 180 minus B gives you this one because it's a straight line. Okay? So let's do what we can do. Okay? Let's do the sine of A. Sine of A is going to be opposite over hypotenuse. See that? So sine of A is equal to opposite over hypotenuse. There's nothing wrong with that. That one's fine. Now, we can rearrange that, we know. H is equal to B sine A, just like before. But how are we going to work out the B one? Okay? We know for sure that the sine of 180 minus b is equal to h over a. That makes h equal to a sine 180 minus b. Okay, so you're thinking to yourself, okay, right. How the hell, how are we going to work this one out? I hear you shout. Okay, but what did we just do in a previous chapter? Sorry, in a previous section, actually, two videos ago. Okay, we had a way of figuring out that this number must be somewhere in the second quadrant. Okay, whatever number it is, it's in the second quadrant. So if it's in the second quadrant, then that b still is the reference angle. So you're still left with h equal to a sine b. Because whatever angle this is, it's greater than 90. That's in the second quadrant. So this becomes the reference angle for this. So they're the same angle. They're going to do the same thing, if you know what I mean. The sine of them is going to be the same. Okay? So let's say you had 120 and this was 60. Sine of 60 is the same as the sine of 120. Okay, you're getting the idea here? It's a reference angle. This is the reference angle you have, which is the same as that angle. So that's why that works. So now we have our two things together. Let's make a sine b equal to b sine a, and divide both sides by sine a sine b, and you're going to get a over sine of a equal to b over sine of b QED. So it's a bit of a cheat, this one, compared to the last one, a tiny bit of a cheat. Okay, so that's what the sine rule does. Okay, now just a little caveat on the sine rule, it works upside down as well. So I'll just use a and b, they're the easiest one to write. A over sine of a is equal to b over the sine of b. But sine of a over a is also equal to sine of b over b. So you can work both ways on it, depending on what you want to find. If you want to find the side, or want to find the angle, it works both ways. That's the beauty of this thing. Okay, so we're going to try one or two just to get you kind of into how this works. Okay, so these are beautiful. I love them to bits. Okay, it's the go-to one. Like after Pythagoras, if Pythagoras doesn't work on a triangle, the first place to go to is the sine rule. 90% of problems in trigonometry will be solved with the sine rule. That's personally speaking. So have a look. I'm going to draw these. I'll draw one or two of them nicely, but most of these triangles I'm just going to draw freehand because, listen, life's too short to be drawing them all nice and neat all the time. Okay, so here's Mr. Triangle. So if this is 8 centimeters, this is A, this is 30 degrees, and this is 40 degrees, find A. Find the length of A. Okay, how would I do it? Well, first of all, I check, is it a right angle triangle? Hell no, so I can't use Pythagoras. So all I'm going to be using now is sine rule because I have 3 parts and I'm looking for the 4th. So A over the sine of 30, remember opposites, is equal to 8 over the sine of 40. It's a basic cross multiplication. Okay, so cross multiply 8 sine 30 divided by sine 40 is equal to your answer. So get your calculator out. That's going to be half times 8 is 6.22 centimeters. And there you have it done. Okay, that's how easy it is. Now, doing it the other way, I'm just going to use a quick one for this. Let's say you have the sides 3.8, 5.2, 35, and you want C. Okay, Same thing again, 3.8 over the sine of c is equal to 5.2 over the sine of 35. Cross multiply 3.8 times the sine of 35 divided by 5.2 is equal to the sine of c. Remember, that's the sine of c, so that means c is equal to the sine inverse of this sum. Give me a second, the calculator. Right, that's 24.8 degrees to the nearest decimal, one decimal place. Okay, so there's your start on the sine rule. Thank you very much. Goodbye.